On October 17, 2025, deep inside the Russian heartland of Starodomak, a TFL-1 first-person view drone enters its terminal dive. The target is now just 500 faft away. In 8 seconds, 8 lb of shaped charge explosive will slam into Russia's largest nitrocellulose production line. But this was just the opening shot. With the entire base now on high alert, would Russian operators detect and stop the second more critical drone before it could deliver the knockout blow? The answer was decided 72 hours earlier while Russia's billion-dollar satellites scanned the skies. Ukraine's plan began its journey on the ground, concealed inside a single unassuming truck. It started with a contract posted on the dark web hiring a local Russian driver for a routine job haul. A prefabricated log cabin 800 miles across the country. The driver had no idea his cargo was a mobile launch platform. Tucked inside the wooden shell, a Ukrainian insider agent was assembling a Gol mothership drone and its payload to TFL-1 attack drones. The genius wasn't just the delivery method. It was the drone's advanced cloaking technology. The TFL-1 used embedded LEDs to emit a thermal signature mimicking a sparrow calibrated to just 2 deg warmer than the surrounding air. To a Russian radar operator glancing at a screen, it wouldn't register as a threat but as insignificant wildlife. The stakes were immense. The objective was to incinerate a 500 million factory and instantly hadal 30% of Russia's explosive production for the Donbass front. This required threading a needle through a dense web of overlapping defense systems. The primary shield was the Tor M2, a formidable weapon with a 10-mi engagement bubble specifically designed to eliminate low-flying targets. Backing it up was the Nebo M radar, which scanned for targets with a low radar cross-section, exactly the profile of the TFL-1. And enveloping the entire area was the Kasuka 4, a powerful electronic warfare system capable of jamming GPS control links and radar systems. To break through this wall of steel and silicon, Ukraine's plan had to be perfect. 3 days earlier, October 14th, the plan went live. A nondescript KAMAZ truck merged onto the M5 highway, its cargo log listing pre-fabricated cabin parts. Inside that shuttering container, it was anything but routine. Under the dim glow of a battery-powered lamp, a single Ukrainian agent worked silently, assembling the Gol mothership piece by piece. The container was lined with military thermal insulation designed to mask his body heat and the electronics' faint warmth from any roadside scans. A GPS spoofer broadcast a fake signal, making the truck's manifest appear perfectly legitimate. Its route logged and accounted for in the official system. For 800 grueling miles, the truck blended in with thousands of others, a ghost moving through the enemy's own logistics network. 50 mi from the Avangard plant, it pulled off into a desolate stretch of farmland. As dusk settled, a section of the container's roof silently slid open. The Gol M, now fully armed, ascended vertically into the twilight, its electric motors nearly silent. It leveled off at just 80 ft, hugging the contours of the Ural River basin to stay beneath the detection ceiling of Russia's long-range S-400 systems. The package was delivered. Now the Gol M had to navigate 50 mi of hostile airspace. The question was, could it reach the drone release point before the more sensitive short-range defenses around the plant even knew it was there? At 0731 p.m., inside a TAR M2 command vehicle, an operator's routine screen sweep was interrupted. A faint intermittent signal appeared ghosting along the river. It was too slow for a missile, too large for a bird, and flying too low for any conventional aircraft. The system's algorithm flagged it as uncategorized biological, but the operator's instincts screamed otherwise. A board commander, annoyed by the alert, gave a dismissive order. Fire a single missile. Let's see if it flinches. A 9M317 missile screamed off its rails. The Gol M wasn't flying blind. Its onboard LAWAR system instantly detected the launch, mapping the missile's trajectory. The mothership dropped another 20 ft its belly, nearly skimming the water's surface. The missile locked onto the drone's previous altitude, shot overhead, and detonated uselessly against a distant hillside. On the Russian screen, everything turned red. The contact was reclassified. Hostile threat level 1. Panic replaced boredom. The commander's voice cracked over the comms. Activate Kasuka 4 full power jamming. Get Spetsnaz on the ground now. A crushing wall of electronic noise flooded the airwaves, a brute force attempt to sever the drone's connection to any operator. Moments later, 200 Spetsnaz operators mobilized, establishing a 5-mile lockdown perimeter around the factory. The element of surprise was gone. The Golem was now flying directly into an electronic hurricane and a closing ring of Russia's most elite soldiers. Its mission wasn't to attack, but to deploy its deadly payload. The question was, had the trap been sprung too soon? At 7:34 p.m., flying into the teeth of the Kasuka 4's jamming field, the Golem M was now a trapped animal, but its purpose was to give birth to the fight. With a clean hydraulic hiss, the mothership's belly doors opened, releasing the two TFL-1 drones into the electronic chaos. For the Russians, this should have been the kill shot. The Kasuka's electronic warfare bubble was designed to sever command links and scramble GPS, turning any drone into a useless brick. And for the first 90 seconds, it worked. The TFL-1's GPS links flickered and died. Except they were no longer listening for commands, they were thinking. Their systems automatically switched to the AI Phantom protocol. The tiny LEDs embedded in their airframes flickered to life, generating that pre-calculated thermal signature just 2 degrees Fahrenheit warmer than a real sparrow. Simultaneously, their flight computers running a neural network trained on thousands of hours of Avon flight data from a Pava Museum archive took over. The drones began executing constant subtle heading changes 4 degrees per second, perfectly mimicking the erratic flight path of a bird navigating across wind. This was the intellectual counterpunch. The 2RM2's sophisticated Doppler filter design to ignore ground clutter and wildlife saw these minute adjustments and immediately dismissed the drones as non-threatening biologicals. On the Russian radar display, the two contacts simply vanished into the background noise. The operators were now staring at an empty screen, utterly blind. One of them muttered in disbelief, "They're flying like they're in the Matrix." They had bypassed the first layer of defense with pure ingenuity. However, this act of digital defiance triggered a far more dangerous response. Realizing their ground radar had been fooled, the Russian command played their ace, and A-50 AWACS patrolling at 30,000 ft was redirected to scan the area. Its powerful look-down thermal imaging systems don't care about flight paths. They only look for one thing: heat. At 7:36 p.m., the moment the A-50 AWACS was retasked, the drone's fate was sealed. From 30,000 aft, the battlefield looked different. The AWACS's powerful thermal sensors didn't care about flight patterns or Doppler shifts. They saw the world in heat. An analyst aboard the aircraft immediately flagged two signatures. They were small, but their thermal output, however faint, was undeniably artificial. The AWACS became the TAWR M2's eyes, with a direct data link feeding it targeting information. The ground battery operator didn't need his own radar lock, he just needed to pull the trigger. A9M317 SAM ignited, punching a hole in the night sky, racing toward the lead drone. The TFL-1's threat receiver shrieked. With less than a second to react, it executed its final pre-programmed maneuver, a suicidal dive. It dropped to just 50 ft, the ground rushing up to meet it, now a mere 500 ft from the facto's walls. But it had dived from one trap straight into another. Below, the 200 Spetsnaz operators weren't waiting. They had deployed their brutal low-tech countermeasure, motorized spools of tripwire strung between trees and poles, creating a spinning web of steel designed to snag and shred any low-flying object. The mission had reached its absolute breaking point. A multi-million-dollar drone was trapped between a supersonic missile from above and a web of steel below. If it failed to reach its target, the hidden AOV ground team lurking 3 miles away would be forced to attack the heavily fortified plant on foot. The entire operation would devolve from a surgical strike into a bloody, desperate firefight. 7:38 p.m. with the SAM closing at 186 MIF. The TFL-1 played its final card. It was the reason this specific drone was chosen, a feature held in reserve for this exact worst-case scenario. The drone system switched from navigation to pure hunting. Its AI abandoned all external guidance and activated its visual homing protocol. The drone was no longer flying toward a set of coordinates. Its optical camera was now scanning the building's facade, cross-referencing the image against a 3D model stored in its memory, looking for one specific target, the main ventilation intake for the nitrocellulose curing bay. As the SAM screamed in the drone's forward-facing LAR painted the missile, calculating its intercept path in microseconds, the AI didn't dodge. It outthought the missile. With a sharp 3 put sideways iodopine, the TFL-1 let the missile overshoot. The SAM's proximity fuse, expecting a much larger target, failed to detonate as it ripped past, eventually self-destructing in the empty sky. Simultaneously, the AI solved the tripwire problem. Its target wasn't at ground level. The ventilation shaft was 40 feet up the main wall, well above the Spetsnaz's primitive steel web with no fiber optic cable to follow back to its source. The drone was a true phantom. Its operators were untraceable. The Goal mothership, its job done, was already banking hard, heading back toward friendly territory. As the first drone lined up for its final 10-second run, the second TFL-1, loitering a mile away, received a simple automated command: wait for flash. Its mission was to use the smoke and fire from the first impact as a massive unjammable beacon for its own attack run. And 3 miles out, the Azov ground team's commander watched a silent video feed from a micro-drone. He powered on their secret weapon, a Termit unmanned ground vehicle armed with thermoaric charges. They weren't a rescue party. They were the Echo, ready to move in and exploit the chaos. The moment the Facto's defenses were shattered, the chess match was over. All that remained was to knock over the king. At 07:39 p.m., the TFL-1 accelerated, its camera fixed on the geometric signature of the ventilation shaft. In the last 3 seconds, the drone was a blur of motion. The 8LB-shaped charge slammed through the steel grill of the main nitrocellulose intake, punching 10 FF into the ductwork before the real show began. The explosion sent shock waves through the factory, a fiery blast that lit up the night sky like Halloween fireworks 2 weeks early. But the real genius wasn't the impact. It was the physics of the detonation itself. This was the anatomy of a perfect kill. First, the fuse. It was programmed with a precise 0.8-second delay. What? Because an instant explosion would have spent most of its energy on the building's exterior. That delay allowed the drone to penetrate deep inside the facility before detonating. The goal wasn't just to make a hole. It was to trap the blast wave where it would do the most damage. Second, the energy release. What happened next was the equivalent of detonating 50 lb of TNT inside a sealed pipe with nowhere to escape. The 500 psi pressure wave smashed against the reinforced concrete walls, rebounding and amplifying its own destructive force. It turned the entire curing bay into a pressure cooker, like locking the Hulk inside a microwave. This pressure didn't just destroy equipment. It shattered the building's skeleton. Concrete support columns designed to handle vertical load snapped like toothpicks when hit by the horizontal shock wave. The main roof gave way, pancaking onto the floor below and crushing the entire production line. In seconds, the nitrocellulose bay was reduced to a smoking pile of twisted rebar and shattered concrete. Finally, the secondary effects. The blast also vaporized the plant's main electrical conduits. The lights didn't just go out. The entire grid experienced a catastrophic failure, a clinical death that plunged the base into total darkness and silence. The Spets teams, now lost in a toxic black cloud with no power and no communications, were utterly blind. In the immediate aftermath, 25 of the plant's senior technicians and managers were instantly